Okay, I'm going to go through the charging and discharging of a capacitor using the DJB ALBA software. So you can see here that I've got a 3-volt supply supplied by 2 batteries here. You can set the power supply to either 3 volts or 1.5 volts, so I've set it to 3 volts in this case. That's then connected to a resistor. The resistor I'm going to start off with is a 1 kilo ohm resistor, and this is a 1000 microfarad capacitor. 2 buttons here, a charge button and a discharge button that I can press to charge and discharge the capacitor, and then this button down here is a rapid discharge button that you'll see referred to once I go into the software here. So if I just hit go on here, you have to set the value of the resistor. So as I already said there, it's 1000 ohms or 1 kilo ohm. SRD, that's rapid discharge, the switch for the rapid discharge. So I'm going to hold that and release just to get any charge that's within the capacitor out of it. I'm ready to go now, so all I do is press the charge button to charge up the capacitor. So you can see here it's the graph at the top that we're interested in, and you can see that the voltage is gradually charging up over time to the full 3 volts of the supply. So that proves that capacitors charge up to the full voltage of the supply. Now if I then press the discharge button, you can see it does the opposite, and you can see there that the voltage is reducing from 3 volts down to 0 volts, where it will remain. So we'll have a look at the sort of time that it's taken to charge up with the 1 kilo ohm resistor and the 1000 microfarad capacitor. So if you just hover the cursor over here, you can see it's around about 7.5 seconds till it gets to that 3 volts. So what we're going to do now is just change the capacitor over and see how that affects how quickly it charges up. So it's just a matter of unscrewing the capacitor here and putting in a new capacitor here. I'm going to use a 220 microfarad capacitor. So just the same setup as before, it's 1000 ohms or 1 kilo ohm. Discharging the capacitor again. And ready to go. So I hit charge again, watching the top graph there, and you can see that it hardly takes any length of time at all for that capacitor to charge up to the full voltage of the supply. Then if I hit discharge, you can see that it discharges much more quickly as well. So all I've done there is change the value of the capacitor from a 1000 microfarad to a smaller capacitance of 220 microfarads. So you can see that the smaller the capacitor is, the faster it will charge up, which is what we would expect. So just to confirm that, we'll just do the same analysis as we did before. Just quickly hovering the cursor over here where it reaches 3 volts. So we're looking at around about 2 seconds there. So it's taken 2 seconds for that to charge up. Now what we're going to do is see how the value of resistance can actually affect how quickly the capacitor charges up. So I'm going to use the same capacitor as before, the 220 microfarad capacitor, but I'm going to change the resistor from a 1 kilo ohm resistor to a 4.7 kilo ohm resistor, or a 4700 ohm resistor. So I'll just do that just now, and I will need to tell the software that I have changed the value of resistance. So it goes from 1000 ohms to 4700 ohms. Again, rapid discharge to remove any charge that's inside the capacitor, and then we'll hit charge again. So this is to go with the 4.7 kilo ohm resistor and the 220 microfarad capacitor. So remember last time it was around about 2 seconds for it to charge up. So you can see there that there's a much slower charging rate there. It's taken a lot longer to get up to that full 3 volts of the supply just by changing the value of the resistance. Now if I hit discharge, it's doing the opposite. It's going from 3 volts back down to 0 volts. So we saw as we reduced the value of capacitance, the time to charge decreased. And then as we change the resistance here, you can see that the greater the resistance is, the longer it's going to take to charge up. So it's actually taken about 8 seconds to charge up this time. So a good 6 seconds longer with a larger resistor. So what we're basically seeing there is that you can change how long it takes a capacitor to charge up by changing your values of capacitance and your values of resistance. So the higher the capacitance value is, the longer the capacitor will take to charge up, and the higher the corresponding resistance value is, the longer it will take to charge up. So you can use that, people who design electronic systems can use that in order to specify how long a time delay in part of a circuit is.